record button. Okay, welcome to AI Integration Working Group weekly meeting. Today is September 10th, and I am your host, Arda Güçlü today. Before jumping to the agenda items, is there anyone who would like to introduce themselves?
Hey, I'm Pandya Raja. Okay, I'm from India. I'm working for Nokia. So, actually, it's a 5G domain. So we are working for this automation thing, the cloud and the base. It's a kind of SRE role. So I'm interested in this AI, and also I want to get to know more about this and base. And I want to contribute more on this side in this Kubernetes work group. Yeah,
Welcome.
thank you.
Hi, everybody. I'll go as well, too. My name is Jeff Doto. I'm a site reliability engineer for Stability AI. And so just trying to get a sense for what's happening in the community right now. Thank you.
Thank you. Welcome. So if there isn't anyone else, I think we can jump on to the agenda items. Today, we have one item, ToolHive demonstration from Chris Stacklock. Chris, do you want to take over?
Yep, sure. I'll share my screen. Disable. Oh, I think I might have to get to be allowed to share.
1 second. I think you are allowed to share, but let me look at the 1 second. Oh, maybe this one. Okay. Okay. Could you please try again?
Yeah, cool. Cool. Yeah, so we've been talking about deploying MCP servers into Kubernetes over the last couple of weeks. We've been talking about some of the challenges around that, and we've had some talks about scalability. We've had some talks around the registry as well. And I think last week it was asked if we could kind of show what we've got as part of ToolHive, an open source project that basically tries to make running MCP servers as easy as possible in Kubernetes, but also as secure as possible as well. So a bit of background. The way that it works currently in ToolHive is we have a Kubernetes operator. It started out as a local command line tool. And if I just very, very quickly open up a tab, that allows you to see the GitHub repo. Okay. This is kind of the GitHub repo for it. It started off initially as a local CLI tool because we saw a lot of people having to run npx commands or pip commands to connect their MCP servers up to Claude or any client that you have. And one of the problems with that is you have to have an underlying package manager, and some of these can go wrong because of just the problem with running native packages locally. Because if you give access to those packages, all hell can break loose in short words. So we built around containerization. So we basically factored that into ToolHive. So how it works is you run a command or a couple of commands, and you'll have a bunch of MCP servers running locally in containers, and they will automatically be put into your client configs. Now, naturally, this is great for individual users locally, but most companies aren't going to just allow you to run MCP servers locally that has access to vital data. So that's where typical in that scenario, companies will want to host those themselves, and where they host them is obviously one of the big questions. But given the fact that they are just very, very small microservice apps, containerization is quite an obvious place for many reasons, especially when you factor in the ecosystem that Kubernetes already has around monitoring and supply chain security and policy and all that kind of stuff. So Kubernetes naturally felt like a good fit because obviously the containerization aspect of it as well. So that then, ToolHive evolved from not just being a ToolHive, a CLI for the local, but also it evolved into being a operator as well. So you can have local and cluster deployments. And that's pretty much what I'll be showing you. So today, what I've got is a local kind cluster running. And if I just kind of go into that kind cluster, all I've done is install an ingress load balancer, but we don't really care about that at the moment because we're not doing things via ingress. I'm just going to do some simple port forwarding for now. But we have a ToolHive.
Would you mind bumping up the font a bit?
The font? Oh yeah, sorry, I have a big screen. My apologies. How's that?
Yeah, that's better. Thanks.
Cool. So there's a ToolHive namespace, ToolHive system namespace, just to follow the system namespaces that you see with Cilium or Istio. So we kind of kept to that convention because it's quite popular and familiar with people. And it's installed via a Helm chart. So it's just 2 Helm charts you need to worry about. There's one for CRDs and then there's one for the operator itself. It could be one Helm chart, but I think it's well recommended in the community to separate your CRDs out into a separate chart for easier upgrading. But it's very, very simple to install. It comes in 2 modes. There's the multi namespace mode and then the cluster-wide mode. By default, it's cluster-wide, so it basically gives the ToolHive operator a cluster role that has access to do things across the cluster. For the very paranoid, companies or individuals that only want it in a certain namespace or only want their MCP servers in a certain namespace, or for multi-tenanted setups, for example. We have a namespace scoped installation version of it as well, which is just a Helm value basically, and it will install the operator in the same namespace as ToolHive's dash system, but it will create the necessary roles and role bindings in the namespaces that you want, so that it only has access to do certain things in those namespaces, leaving all of your other namespaces safe from its access. So that's pretty much the kind of intro. It's just one running pod, and what I'll do now is I'll just apply a CR. So we've got a custom resource called MCP server, and it's got all the familiar things that you probably are aware about. So it's got namespace, name, image. I'm using a GoFetch, which is something that I built because I wasn't particularly happy with the fetch server because it didn't support all transport types, and it didn't really have good containerization practices, and it was run as root, and a myriad of problems. This one is a bit more secure. It's got a bit better logging as well for it. And the transport type I'm choosing is streamable HTTP. And I want it to be running on port 80, and I also want the proxy that gives it access to run on port 80 as well. It's worth mentioning these port names will actually change just so they're a bit more intuitive because there has been confusion about what port is and what target port means. So we'll be renaming those to be a bit simpler. But ultimately, the port is the MCP port, so the port that it runs on, and then the target the port is a proxy port, and the target port is the MCP server port. Permission profiles, that's just built-in network profiles that we have that share what the functionality that we have locally, and then the standard resources stuff you see as well. There are a bunch more items you can add here. You can add hotel stuff. So if I was to go into a specific example that we have for OTel, you'll see a bunch of telemetry stuff there. So this allows you to see usage on your MCP servers in Grafana or whatever monitoring stack that you have. All we do is we export metrics or tracing information to an OTel collector. And also, if you want, we enable a Prometheus endpoint where you can scrape the metrics as well. Sample rate is 1 because it's just an example. So, you don't want to have to fire 100 requests just to see one trace. But yeah, so there's a couple of examples on there, but the one that we'll be caring about a bit today will just be this simple one. So what I'll do is I'll apply this and I'll talk you through what behind the scenes happens. So what happens is the ToolHive operator will see that MCP CR, and it will know that you obviously want to create an MCP server. Now, there's a couple of things that happen, and there's a couple of conditions that happen. So depending on the type of transport that you have, depends on what resources are created. So if it's an SDIO server, then it will only create a proxy service, which you would have access to via this thing here. And this is what you talk to, basically. And this talks to the proxy pod, which is where ToolHive comes in the middle, and it kind of proxies requests and registers the middleware for all open telemetry stuff. That's SDIO. Now, with that, you'll have this service, but in the back end, because of the nature of SDIO, the proxy itself will be attaching to the underlying MCP server via standard in. Now, that's great, it works. However, as you can imagine, that doesn't scale. And we've actually written blogs on how that doesn't scale, which is why streamable HTTP is currently the recommended way of deploying MCP servers in production. And there may be other transport types in the future, but currently streamable HTTP is kind of the better one. It's just more scalable. And in that case, which is the one I've got, it creates two services. So it creates a proxy service, which is exactly the same as the standard SDIO setup, which gives you access to the ToolHive, the fetch proxy, as the proxy runner we call it, which is this pod here. And there's another service called headless service, which allows the proxy pod to communicate with the underlying MCP server itself. Now, the proxy pod is a deployment, whereas the underlying MCP servers are a stateful set. And that's kind of the overall, that's a simplified version of what happens. There's documentation of all the diagrams that you need to look at that describes this in kind of one picture. So if I'm not doing a good job of explaining that kind of stuff, then there's an easy diagram that shows you all this pretty nicely. But that's ultimately the simple scenarios. So to access this, normally in a production case, you would just point your ingress controller, or however you set it up. You would point it to your service, which in this case would just be the proxy service here. But given the fact that I haven't got I don't want to have to mess with ingress load balancers at the moment. I'll just keep it simple. I'll just do a port forward. So what I'll do is I'll just port forward this service, which will naturally port forward it to this pod here. And if I go into this pod, just to show you some pod logs, I will now. So I could either use Cursor to connect to this, but just to reduce the amount of stuff going on my screen, I'll just use curl. It is quite an easy way of doing that. So this curl command, basically, in a nutshell, will go to the local host forward 8080, which is where I port forwarded the proxy on, and it will ask for it'll initialize the session, and at this point, it will get a session ID back, which I'll put in this little variable here. So that's what I'll run that. So as you see, there's a server was initialized log there. I'll go into it because some of the logging lines are a bit cut off. But as you see, server initialized successfully for fetch. Now, if I post, so all I want to do is I want to get the README content for the ToolHive GitHub repo. That's all I want to do here. And I'm going to be using that session ID that I just got back from the initialize request. And that's the content of it, right? So if I want a little bit less content, I'll just adjust the max length to like 100 or something, and I'll just get 100 characters back. Now, if we go to the underlying MCP server, you'll see that there's some logs there just detailing that, you know, this happened, basically. These requests happened for this URL. That's something I don't think happens on the underlying fetch, the MCP/fetch server. At least it didn't when I built this. So maybe they've added some logs, but this is just kind of a nice indicator that it's actually responded to requests, because that was another problem I had before, is that I could never actually tell if the underlying fetch MCP server actually was responding to things. So those logs help a little bit more. And that's kind of a simple example. Now, obviously, GoFetch, you might not run that in your production cluster. We've got another MCP server called MKP, which is just the Model Context Protocol K for Kubernetes, which allows you to install this, which allows you to perform Kubernetes operations inside of the cluster using an MCP server. And we've got examples of deploying that with, in fact, let me give you a example. MKP, this one. Oh, no, didn't want to create it. I wanted to open it. My bad. So there's a couple more things in there. And just because we want to restrict what access that underlying MCP server has, so we created a dedicated service account for it. And we're just saying read, write, false. So that's one of the flags that you give it. And what this will allow you to do is communicate to it via ingress or port forwarding, and just naturally, like any MCP server that you're used to, you're able to connect it to your clients, like Cursor, for example, or whatever clients you use, and it allows you to query what's going on in your cluster, and depending on the type of access you've given it, will depend on what it can do for you. So if you give it completely cluster role access, like this very simple example here gives the cluster admin role, in this scenario, the MKP will have access to everything. So in a demo, that's quite a nice thing, because you can demo things. But in a production setup, you might not want to do it that way, right? But you know, those are just simple MCP servers that we've kind of used to package. That we use as examples when deploying with ToolHive, and we've got some good feedback on those. And that's pretty much it. I mean, it's not much. I don't really want to go into heavy details on anything else, because I think that's kind of a good high level approach. And Jakub, is there anything that you think that I've missed that might be quite key to add?
Not on the introductional level. There's more things that you could go to, like, you know, authentication, authorization, auditing. Yeah, you covered it well. Thank you.
Cool. And yeah, there's the documentation for it. So there's here's your image in a picture paints 1,000 words here. So it's if I didn't do it justice, here's a nice image to show you how it works. But yeah, and if there's any questions, fire away. Otherwise, I'm happy to hand it back over.
Thank you for the demo. I think ToolHive is nicely fits onto the Kubernetes cluster, because it uses the built-in methodologies. I have a question about what is the reason of using the stateful set instead of the deployment?
Yeah, so that was a question I had originally. So I believe the answer was, I don't think he's on the call, so he can't correct me if I'm wrong. I believe the answer was because they were networking components that they may have wanted to persist. So they didn't want to have to deal with the downsides of what would happen if you used the deployments. It's still something I'm not completely 100% sure on because I didn't dig into the details of what the person meant. But yeah, that was the answer I got at the time. Was there were stateful aspects which were only best suited for stateful sets. However, if that doesn't apply in the same way anymore, we'd be the first ones to switch that over to something like a deployment. In fact, we're quite happy with. There were some decisions that were made in the past that we're happy with changing right now, which is like things like the architecture, for example. So there's little things around the architecture that we want to improve on, just because of lessons learned more than anything. And if we find out during scaling, stateful sets doesn't actually matter that much, then yeah, we probably would move to a deployment just because of how easy they are to deal with. I don't know if Jakob, if you know the answer to that. I didn't dig any deeper when I saw
I didn't. This was before I started working. I always thought it has to do with predictability of something, but I forgot the details.
Yeah.
By the way, it makes sense to me using the stateful sets because MCP servers may want to cache session IDs or the bearer tokens, etc. And after the restart, instead of forcing to everyone logs into again to get these kind of data, it makes sense to use the stateful sets.
I think that now you've said that, I think that may have been one of the primary reasons. Yeah, I forgot the details, but I think that might have been one of that rings a bell. So that I think that was one of the reasons.
Yeah, so I think great demo. Thanks for sharing. So do you have any features around like scaling up or down depending on demand, or any data around how many users like particular servers can handle? For example, if you're doing the Kubernetes MCP server, most likely it won't be able to scale beyond a certain limit, right? Then you have to look into, oh, how do we horizontally scale it, whether it's stateless or not, and so on.
Yeah. So we did a load test around MCP server scaling. So we had some suspicions that SDIO just wouldn't scale that well, whereas we kind of had a feeling that SSE and Streamable would scale a bit better. And when we ran the tests, the load test for that, it was proved to be quite true. In fact, I think SDIO scaled horribly bad, to a point where I think I ran a test where it was like over 60 seconds, 5 concurrent threads pinging, I think, an average of 1 request per second or something, or 2 requests. I forget the numbers. It was very, very, very low numbers. And I think only 2 requests succeeded. Now, the problem wasn't because they weren't getting through. The problem was that because of the nature of the standard in and standard out, when you can easily send requests through and get responses. It's just the response that you get back isn't always going to be the response that you want back. So in the test that we had, we would echo you would send a request with the input saying hello world, and then the response coming back should be hello world, just so you can verify that response was supposed to be the one that you got for your request. And we found that out of all of the requests except for 2, they all got different responses back, which just shows it kind of theoretically makes sense because that's just standard input and out, right? Is that you can't guarantee what's going to come back when and where. But in terms of SDIO, I think if for us to solve that problem, I think we'd be reinventing a wheel somewhere. And I think the argument from others, and in fact myself, is would we even want to bother with that when we know streamable HTTP MCP servers are probably what's going to be used in production? And I think that's what we recommend anyway. I don't necessarily recommend running SDIO MCP servers in production where you expect quite a lot of load. They're okay given one-offs, but I think if you're going to have quite a lot of requests going at it, it might be a little bit trickier than just firing a request at MCP server. On the streamable side, they scaled pretty well to like I think 30 requests per second, which is it's not low. It's not Google level, but that's if you think of how slow AI requests are for MCP and how the fact that a lot of the request lifecycle, the request and response lifespan, they're quite long. They're not in the milliseconds. Things have to think. So 30 requests per second, I think it was, and that was just by default. I think we haven't really done any future work around scaling that to thousands of requests per second, just because I don't think we need to at the moment. There have been talks around adding external components like Valkey or just for caching and just making sure that if one proxy goes down, then you've not lost all your sessions, things like that. But in terms of scaling to like supporting thousands of requests per second, I don't think that's I don't think that's a problem at the moment that people are having. I think they're still in the zone of how do we run these in Kubernetes.
Yeah, thanks. So I think recently there was this proposal opened, which is around making the specifications stateless by default. So it's worth engaging on if folks have thoughts on it. I shared it in chat.
Okay, then is there any comments, opinions, or questions?
I would be curious on how authentication works, but I mean, that could be a separate discussion entirely.
In MCP in general or in ToolHive?
With ToolHive, like what model do you have? What kind of authentication schemes you support?
That's probably I'll have to rely on my trusty friend Jakob for that one. I think he's the auth master and when it comes to that stuff.
Yeah, I guess we can line it up for an upcoming call, and maybe we can also share with SIG auth, so we make sure we get folks from there
Yeah.
that are interested.
Yeah. I'll be happy to talk about it in their like future session. The biggest problem with the MCP space is that the MCP servers kind of out of the box, the off the shelf that you install, are written in kind of naive ways that presume that they are used by one user on desktop. The most typical way of provisioning them with credentials is you just give them an environment variable with some secret. And that's really, it doesn't work super well in multi-user scenarios where you might have something like a Google Doc MCP server and you want every user to see just their docs. There's different techniques, but then for projects like ToolHive or others, it's not specific to that project. The biggest obstacle then, or uphill battle maybe, is that you can promote best practices, but you kind of also need to write the MCP servers yourself to use those. And then that's fine if you're writing the MCP server for your internal use, and then yeah, it would make sense to have them and use them. But for a kind of consumption of MCP servers that you download from a public space, yeah, more of a working around around the anti-patterns that have emerged, unfortunately.
That makes sense. Yeah, because it mostly depends on the implementation of the MCP servers, and ToolHive is mostly run these images actually with subset of functionality decorators, but internally what this MCP server is also mattering. Okay.
I guess like one more area of exploration is how these MCP servers or like maybe kubectl AI and how these projects actually interact with Kubernetes server. And one is a life cycle aspect, which we covered in the call today a bit. But I'm wondering if folks are open to describing their approaches, like how they are building Kubernetes MCP servers, and maybe we can dive into the details there. I see like Sunil on the call if he is up for a kubectl AI talk at some point.
Sorry, actually, I missed it. Can you repeat?
Yeah. So I was wondering, like, one more topic of exploration for the work group is how Kubernetes MCP servers / AI interact with Kubernetes servers. So maybe we can how different projects describe their approaches and compare notes and see if we can come up with any best practices or learnings. And I know you've taken a kubectl based approach. We have a kubectl, Kubernetes MCP server, and I think Stacklock also talked about one.
I see. Yeah, I mean, this is still an experiment where we exposed kubectl as a tool in kubectl AI. Yeah, we can definitely talk about it. We also, from GKE side, there's also a couple of MCP servers that are open source. There's one GKE MCP. So yeah, we can definitely talk about it in the next sessions, maybe. Even have a demo or something to make it more concrete.
Yep. So sounds good. So I think if we can line up more demos for next week, and folks can add it to the agenda. Yeah.
Yeah,
Sure.
that would be nice. Sunil can correct me, but as far as I know, kubectl AI supports running MCP servers via std.io, since this is an CLI tool, basically.
So yeah, so it's a little confusing. So since kubectl AI is a client, so it has an MCP client where it can talk to other MCPs. It can talk to MCP servers and support all the so that it can invoke tools exposed by MCP servers. But at the same time, it also has another mode, which we call it MCP server mode. So if you run it in the MCP server mode, then it uh, ex- then it exposes kubectl as a tool. Like it basically it acts as an MCP server in that case, not as a client. So then, yeah, other clients like Cursor or any client that supports MCP servers can use the kubectl tool exposed by kubectl AI MCP server. I know it's like too many. So it has two modes, just to summarize. One, it can actually act as an MCP server, and it can also act as an MCP client. Yeah. And the why we decided to kind of expose the MCP server as well, it was purely an experiment because the space is so early, so we wanted to see if anyone wants to use it. uh, so that's because we also saw other approaches where people would be wrapping the API endpoints of Kubernetes API server and exposing all those endpoints one on one as MCP tools. And so we wanted to do this experiment. There is a lot of issues and feedback in the community about it, and on the repo, I actually would have to look into it to kind of synthesize all the feedback. But it's mostly as an experiment.
Thank you. So if there isn't any more comments or questions, this is the end of the agenda items today. I think we can end up the meeting. And I can give you your 23 minutes back. Thank you, and see you next week.
Thank you.